In this video, we will learn about electrical energy. Let on applying a potential difference V, a current flow R and through a resistor R. So a current flow is I through a resistor R. Let T be the time for which the current flows. Now we know that I is equals to Q upon T, which is the rate of flow of charge. So the total amount of charge will be Q, which is equals to I into T. We will multiply T here. Now we know that as per the definition of potential difference, the amount of work done for flow of unit charge V, and we know that work done is simply equal to V into Q. So work done is equals to V into IT. We will put the value of this Q here and we will get W is equals to VIT. To do this work, the source of electricity must apply an electric current and electrical energy E such that E must be equal to work done, which is equals to VIT. Hence, our value of electrical energy E is equals to VIT. Thus, electrical energy consumed in an electric circuit is given by the product of voltage, current and the time of the current flow. So, E is simply equal to V, that is voltage, into current, that is I, into T, that is. So its SI unit is simply as similar to the work done, which is joules. So as voltage is equals to V is equals to IR or RI, hence electrical energy also be expressed as by putting the value of voltage here. So let's just put the value of voltage. So here this is V is equals to IR, and what we will get is we will simply get I square RT. So this is another formula for electrical energy. Electric power. The electric power of an electric circuit is simply the rate at which this electrical energy is dissipated in the electric circuit. If E energy is being dissipated in the circuit during the time, then the power of the circuit is simply energy divided by time. E by T is the power or electric power. So the SI unit is of power is watt, and 1 watt is equals to 1 joule divided by 1 second. Why is it so? Because it is, if this is 1 joule and then the time is 1 second, then we can simply say it is equals to 1 watt. As electrical energy dissipated in the circuit is E is equals to VIT, hence electric power can be written as E upon T, and we will just put the value of E by T, that is E, that is VIT here, and T and T will get cancelled with each other. So we will simply get VIT. Sorry, VI only. Next. Thus, electric power in watts, that is equals to potential difference in volts into current in ampere. It means that 1 watt is equals to 1 volt into 1 ampere. In other words, power consumed is 1 watt if a current of 1 ampere flows on applying a potential difference of 1 volt. So here are various multiples of watt are as follows. Kilowatt, that is equals to simply 1000 watt. Megawatt, that is equals to 10 raised to power 6 watt. Gigawatt, that is 10 raised to power 9 watt or 10 raised to power 6 kilowatt. Power rating of electrical appliance. You might have seen words like 100 volt and 100 watt and 220 volt marked on an incandescent electric bulb, or 40 watt 220 volt marked on a fluorescent tube. When we say that an electric bulb is rated as 100 watt and 220 volt, what does it mean? It simply means that the power consumed by the electric bulb is 100 volt when it is operated on 220 volt electric supply. Again, rating of 40 watt and 220 volt on fluorescent tube means that simply the tube will consume a power of 40 watt when again it is operated on 220 volt electric supply. Thus, power rating of an electric appliance device gadget indicates the amount of power it uses or even generates when operating at a specified voltage. The power rating of an electrical appliance gives us the following information. First of all, it simply signifies a proper value of operating voltage for working of an appliance, which is like 220 volt. So if the appliance is operated at a lower voltage, then simply it will give less power. On the other hand, if the appliance is operated at a higher voltage than the rated value, then again it may be damaged. So we can calculate the maximum safe current which can flow through the appliance by this formula, that is power is equals to Vi. So the maximum safe current is simply equal to P divided by V, that is power rating of appliance divided by operating voltage. We can calculate the resistance of the given appliance by using the relation R is equals to V upon I. I hope it is clear to you. Thank you.